Question 6. Mariah is shopping for pencils and erasers to give to her piano students. She can purchase at most 50 total items. She wants the number of pencils purchased to be greater than the square number of erasers. Create a system of inequalities to model this situation and use it to determine how many of the solutions are viable. Which statement is true about the solution of the system? So let's come up with our system of equations in this problem first. So we know that the number of pencils purchased, we know a total, at most, she can purchase 50 total items. Well, what are our items? There are pencils and there are erasers. So pencils plus erasers has to be less than or equal to 50. That's what the word at most means. It means it could get to 50, but it's never going to exceed 50. It's going to be less than or equal to 50. And then my other inequality, she wants the number of pencils purchased to be greater than the square number of the erasers. So here's our two inequalities. And then as I'm looking at the solution, we're trying to determine if either part of the solution is viable or the entire solution is viable. So what we need to do next is we need to graph this. So what I'm going to do to make this easier to graph is I'm first off going to change the variables to the more familiar y and x. So I'm going to replace p with y and e with x. And obviously, I'm going to do the same thing in this top equation. So this bottom equation is pretty straightforward to graph. We could use a graphing calculator, but I just know that this is a parabola that sits on the origin. It's going to look something like that. I made it probably wider than it needs to be just so we can get a good full picture here. So there's our first inequality. And notice the solutions are the solutions where y is greater than x squared. So that's everything above this parabola. I'm going to use a light color to actually shade. I know my potential solutions are above the parabola, really on the inside of the parabola. So right there are the potential solutions. Of course, those go up forever and ever. All right, now we're going to take this other inequality. X plus y is less than or equal to 50. I'm going to put this in slope-intercept form by subtracting x from both sides. We're left with y is less than or equal to negative x plus 50. So we're going to estimate this, of course, but the y-intercept of 50 is going to be way up here somewhere. We'll just call it there. And then the slope is negative 1 over 1. So that means we're going down 1 over 1. So the general shape of the graph is going to look like this. And we're shading everything where y is less than negative x plus 50. So that means we're shading everything below this line. So specifically, remember, we're looking for where it overlaps so we can kind of see where it overlaps. So that is my complete set of solutions where the green and yellow overlap. I'm going to kind of circle it the best I can in blue there. In fact, let's make it nice and dark and blue just to show this is where the overlapping is happening. So then the first choice is no part of the solution region is viable because the number of pencils and erasers purchased cannot be negative. Well, the second part is true. The number of pencils and erasers purchased cannot be negative. You can't purchase negative 10 pencils or negative 10 erasers. But we'll notice that, first off, in this shaded region, the y-coordinate is always positive. But the x-coordinate is sometimes negative. So like in this region right here, like these are negative x coordinates. And this is what we're talking about when we're talking viable. Like those aren't viable solutions because you cannot have negative pencils or erasers in this problem. Now, we do see there are some areas that are purely positive. So the pink is okay, but the green over here, no, sorry, the green is okay because this is where the x and y coordinates are both positive, and that's what we want. We want positive number of pen and pencils and erasers sold. The pink is not okay because we've got negative of some item there. So then the question ultimately is, okay, when x is negative, we should have recorded this at the very beginning, but when x is negative, what does x represent in this problem? Does it represent pencils or erasers? Well, to go back to that, we had y was greater than, oh, it's kind of hard to see now. We had y was greater than x squared. So x, remember, the x squared came from right here, the squared number of erasers. So the erasers are the x. So some part of this solution, the number of erasers sold, are negative. And you cannot have a negative number for erasers purchased. So that's this option right here.